So when thinking about the limiting reactant and applying it to this specific reaction, we have to go through the process to figure out which reactant would be completely consumed and limit how many times this reaction can occur. So when looking at this reaction, you have your reactants, you have your product. So your reactants are to the left, product to the right. So this specific reaction said that if you had 6 grams of aluminum and 11 grams of sulfur, which reactant would be the limiting reactant? So in other words, which one would run out first? So there are different ways in which you can do this. One of the easiest ways is to simply take the amount of each reactant that is present and figure out how much of the product would actually form. By doing that, whichever one forms less product would represent the limiting reactant. And so, in order to determine how much product would form, because you're starting with gram, we can then figure out either how many grams or moles of the product would form. In chemistry, mole represents the SI unit for the amount of a substance. So technically we can figure out how many moles, so what amount of that substance would form. But either way, because you're relating or comparing two different things, the only way you can compare things, different things, is by looking at the mole to mole ratio. This is done using a balanced chemical equation. So this equation is already balanced, so you were provided with the balanced chemical equation. The mole to mole ratio basically utilizes the coefficients which tell you how much of each component is either needed or formed during that reaction. So with this particular reaction, this 2 and this 3, there's an invisible 1. All of those are basically telling you how many moles of those substances are needed or formed during that reaction. So for every 2 moles of aluminum that reacts with 3 moles of sulfur, they will produce 1 mole of aluminum sulfide. And so in order to identify your limiting reactant, figure out based on the amount of aluminum and based on the amount of sulfur, what amount of the product would actually form. And so in order to do that, again, we have to compare the mole. But right now you're given gram. So you have to think about the relationship between the gram and the mole. So in other words, how can you convert your grams of aluminum to moles of aluminum? In order to compare the gram of any substance to the mole of that same substance, you have to use what's called the molar mass. Now, depending on your textbook, it may say molar mass. It may say molecular weight or chemical weight. They are all very similar, but there are small differences between them. They're all calculated the same way. But what's different is the unit and what type of compound it represents. And so in order to determine the molar mass of any atom or element, you would simply refer to the periodic table. So for aluminum, you would simply locate it on your periodic table and the mass number, so the average mass number, so the number you see at the bottom, so the 26.98. That tells you how many grams of aluminum are present in every mole of aluminum. So that tells you the relationship. For every 26.98 grams of aluminum, that is the same as 1 mole of aluminum. So that shows the ratio of those components. But again, we can show it as conversion factors. So it could have also been shown, so I can say, or we can show it as 26.98 grams of aluminum over 1 mole of aluminum. Or it could have been flipped and shown the opposite way. 1 mole of aluminum over 26.98 grams of aluminum. Which you use will depend on what you're starting with. So which one you use will depend on where you're starting at. So you'll definitely be using one of these conversion factors. But depending on where you're starting, that will determine which conversion factor you will use. And so from there, we can convert those 6 grams of aluminum to moles of aluminum. So using the conversion factor, I need to get rid of the gram. So since I have gram up top, I need to put the gram on the bottom. That means that my mole will go up top. Looking back at the conversion factor, 26.98 goes with the grams. So I'm still going to keep the 26.98 with the grams. The 1 will go with the mole. So from there, you can do the calculation. My recommendation, don't calculate just yet. I prefer to do one long setup and then carry out the calculation. That way you don't have to worry about a rounding error. Because remember, the goal was to figure out, based on the amount of aluminum, how much of the product could actually form. And so I'm going to go ahead and do the calculation, and then I'll come back at the end and show how I would have set it up if I were actually doing the problem myself. So put in your calculator, you have 6 times 1 divided by 26.98. And when you put that in your calculator, you'll get 0.2224 moles of aluminum. So I have more significant figures that I need, but that's because you don't want to round too soon. So that tells you how much of the aluminum you have using the unit mole, but we need to figure out how much of the product could actually form. In order to relate the amount of aluminum to the amount of aluminum sulfide, we have to use that balanced chemical equation to do the mole to mole ratio. Because what this reaction tells us is that for every 2 aluminum, we can form 1 of the product. And so since we know how many moles of aluminum we have, we can then figure out how many moles of the product are present. I apologize for the interruption. My computer went out somehow. But let me start back with where I was at. Now that we know the amount of aluminum, we can figure out the amount of the aluminum sulfide, so the product. The balanced chemical equation tells us that for every, switch colors, that for every 2 moles of aluminum, we'll form 1 mole of the product. And so since we already know how many moles of aluminum, we can set up a conversion factor to then convert from aluminum to the product, aluminum sulfide. So I have the ratio, but as we've seen before, that could also be shown as fractions to represent the conversion factor. So anytime you're showing conversion factors, there are always 2 different ways that you can show that same conversion factor. So show how those units are equivalent to one another. They both represent the same thing. So from there, we can use the amount of aluminum that we already know is present. So that 0.2224 moles of aluminum, to then figure out how many moles of the product. So I need to get rid of moles of aluminum. Since they're up top, I'm going to put them on the bottom. But what I want is moles of aluminum sulfide. Based on that balanced chemical equation, which we've already shown as a ratio, for every 2 aluminum, we can form 1 aluminum sulfide. So we simply put those numbers in. 2 moles of aluminum for every 1 mole of aluminum sulfide. So your moles of aluminum will cancel out, leaving you with moles of aluminum sulfide. Put that in your calculator. 0.2224 times 1 divided by 2. When you put that in your calculator, you'll get 0.1112 moles of aluminum sulfide. Now I mentioned that I'll show how I would have just set it up from the very beginning. From the very beginning, I would have just did one long calculation. I would have started out with my grams of aluminum. Use my molar mass to show the ratio or the relationship between grams of aluminum and moles of aluminum, which was 26.98 to 1. And we got that from the periodic table. Then I would use my conversion factor to show how many moles of aluminum are needed for every mole of aluminum sulfide produced. And so that's based on your balanced chemical equation. So those coefficients tell you how many of the reactants are needed, how much of the product is formed. So for every 2 moles of aluminum, you have 1 mole of your aluminum sulfide product. From there, you can look at how the units cancel. So we can get rid of grams of aluminum. We can get rid of moles of aluminum. What you would be left with is simply moles of your product. You can do the calculation. 6 times 1 times 1 is still 6, divided by the product of 26.98 times 2, and you'll still get the same answer, 0.1112 moles. So even if you break it up, or if you just carry out one long calculation, you'll get the same thing. The key is just making sure that if you break it up, don't round too soon. So don't show this as 0.2 because that'll throw off your final answer. You want to have extra significant figures. So that is just one reactant. But then we have to turn around and do the same thing with the second reactant. The process is going to be the same, but the numbers are going to be a little different. So now we're still going to use the same process. But instead of grams of aluminum to moles of aluminum, now we're starting with grams of sulfur to moles of sulfur. Because again, in order to determine the amount of product formed based on the amount of sulfur, because we're comparing two different things, we have to use the mole. So anytime you're comparing two different substances, the mole is how you make that comparison. So I need to figure out a way to compare sulfur to aluminum sulfide, which means I really need to compare moles of sulfur to moles of aluminum sulfide. So the previous reactant, the aluminum, we went through step by step, showed the pieces. Here, we can start putting certain things together. We know that we're going to have to go from grams of sulfur to moles of sulfur. Then we'll have to go from moles of sulfur to moles of our product, the aluminum sulfide. So instead of breaking this one up, we'll just do one long calculation. Again, the process is the same. It's just that we have to look at a different molar mass. So again, we have to go back to the periodic table, locate sulfur. Sulfur has an average atomic mass of 32.06. That 32.06 that you see on your periodic table tells you that for every 32.06 grams of sulfur, that is the same as 1 mole of sulfur. So that is our ratio, but remember again, we can show it as conversion factors, which are basically fractions. So we can still show how the gram of sulfur relates to the mole of sulfur. And just as before, we can show it two different ways. So now we can start setting up our problem. So we can set it up so that we can perform that calculation. So starting with what was given. We were given that with this problem, you have 11 grams of sulfur. This kind of roadmap basically guides you through the process. We're going from grams of sulfur to moles of sulfur. So we need to go from grams of sulfur to the moles of sulfur. So we need to get rid of the grams of sulfur. So since they're already up top, we have to put them on the bottom. But we need moles of sulfur. Again, your molar mass or your chemical weight, it's telling you how these two components are equivalent or how they're equal to one another. Periodic table tells us that for every 32.06 grams of sulfur, we have 1 mole of sulfur. So at that point, our grams of sulfur have canceled. We were left with moles of sulfur. But we're not finished yet. We can just go ahead and keep calculating. We want to figure out how much product is formed. So we're going to get rid of the moles of sulfur because what we're really interested in is how many moles of aluminum sulfide would actually form. So again, these numbers come from your balanced chemical equation because that balanced equation tells us that for every 3 moles of sulfur that react, 1 mole of aluminum sulfide can be produced. So it's telling you how these are related to one another. So at that point, our moles of sulfur have canceled. So the unit that we're left with now would simply be moles of aluminum sulfide. From there, carry out your calculation. You have 11 times 1 times 1 divided by the product of 3 times 32.06. When you perform that calculation, turns out that you have 0.1144 moles of product that would form. So if you were just trying to figure out how much product could form based on sulfur, you have that. If you're just trying to figure out how much product could form based on the amount of aluminum, you have that. But the goal of this was to determine or identify your limiting reactant. So just so that we're working with one sheet of paper, so we have the amount of product formed based on the amount of the sulfur. Going back to the amount of aluminum. So if we started with 6 grams of aluminum, we would end up forming 0.1112 moles of product. 0.1112 moles of the product. However, if we start out with 11 grams of sulfur, we would end up producing 0.1144 moles of the product. So in order to determine which one is your limiting reactant, it's going to form less product. So 0.1112 is less than 0.1144. So that means that these 6 grams of aluminum would form less product, making the aluminum the limiting reactant. So just because we had 6 grams of aluminum versus 11 grams of sulfur, that's not what determined which one was the limiting reactant. The limiting reactant was determined based on which would form less of your product. So again, this is one way that you can do these types of problems, but it's not the only way. In my opinion, it is an easier way to do the product by comparing how much of each reactant or how much reactant would form the product. So based on each amount that is present, how much product would actually form. Whichever forms less of the product allows you to identify your limiting reactant. So your teacher or your instructor may show you a different way, which is fine, but the concept is still the same. The limiting reactant, it limits how much product would actually form.